Hello children and welcome to the session today. Children, we have learned about so many different things that we have to eat in our environment. And amazingly, all these things taste very different. So much so that even our tongue has got different areas to spot the different tastes around us. Imagine if you were given food that tastes almost the same everywhere. What is going to happen? Will you like it? I'm sure you wouldn't. So what do we need in our life? We need taste and flavor. And that is what we are going to understand today. One of the component of these taste that we get in various foods. So let us begin with chapter number 6, acids, bases and salts. Now we are going to learn about their properties, how the salts are prepared and what are the uses of different salts. To begin with acids first, a very simple experiment that is given in your book here asks you to pick up a few substances as you can see on your screen. Food grade vinegar, lemon juice, orange juice, sour milk, curd and tamarind. The book asks you to taste all of these and write how do they taste. So tell me, how are they going to taste? They are going to taste sour. And why do they taste sour? Because of the presence of acid in it. So acid is a substance that is sour to taste. Now all these items that you saw here, they are either obtained from plants or other organisms. What are these called? These are called organic acids. That means the acids that are found naturally. Now there are some industry made acids which are known as mineral acids. What are these acids? Carbonic acid, hydrochloric acid, sulfuric acid, nitric acid and phosphoric acid. So what are the two kinds of acids? Organic acids and mineral acids. So is there any other difference between the acids? Yes. The acids can be strong and weak. Organic acids are usually weak acids. So we know that we can taste vinegar, lemon juice and all these things. But mineral acids are very strong acid. Even if a tiny little drop of a strong acid drops on your skin, it can burn it very vigorously. That is why we have to be so careful in the school laboratory. Then there are dilute and concentrated acids. So some acids are made diluted by the addition of water. And some acids that have got less amount of water are concentrated acids, which again are very, very dangerous. Coming to the physical properties of acids. So acids are sour in taste. And when you add water to acids, what do they form? They form acidic solutions that conduct electricity. Acids corrode most of the substances with which they come in contact. That is the reason if you visit the school laboratory, you will see acids kept only in glass containers. Concentrated acid burns sugar and paper. Which acid is this? This is sulfuric acid. Then concentrated nitric acids react with protein present in the skin. Even concentrated hydrochloric acid will burn the skin and change it to which color? Amber red. Now let us understand the chemical properties of acids. Physical properties means whatever they do. Physical properties means however they look. What are chemical properties? Chemical properties is how they behave when they are kept in the presence of different things. Here, the first example that we are going to study here is reaction with metals. So metals like zinc, sodium, potassium, magnesium, iron, aluminium replace hydrogen present in acids. So if metals react with acids, what do they release? They release hydrogen. This hydrogen is released in the form of gas. And children, all the metals which can react with acids are known as active metals, and the metals that do not react are known as non-active metals. What are the examples of non-active metals? Gold, silver and platinum. Now let us understand their reaction with carbonates. Dilute acids react with carbonates of metals, and what do they give out? They give out, as we can see here, this is a carbonate, magnesium carbonate. When it reacts with HCl, hydrochloric acid, it gives magnesium chloride and it gives water and carbon dioxide. Similarly, when sodium carbonate reacts with sulfuric acid, it also gives out H2O and water. Now, there is a simple experiment by which you can see that whether carbon dioxide is released or not. You can read it from your book and conduct it in the presence of your teacher. Now, moving next to bases. Now, what are bases? Children, there are acids and then there are bases. So, acids we know they are sour in taste. What are bases? Bases are soapy to touch. So, what happens when an acid and a base are put together? They neutralize each other. And what is a reaction called? It is known as a neutralization reaction. So, children, if I mix an acid into a base, I get a salt. If the acid and the base are equally strong, what will happen? This salt is going to be totally neutral. If I take a strong acid and mix it with a weak base, what am I going to get? I am going to get an acidic salt. Let's do the reverse. I take a very strong base and I add it to a weak acid. What do I get? I get a basic salt. So, by acidic salt or by basic salt, what do I mean? I mean that the salt that is formed will have the properties of either of the two. So, in case it is neutral, it is a complete neutralization reaction. In case it is either acidic or basic, it is an incomplete neutralization reaction. Now, let us understand the use of some different acids in the industry. Hydrochloric acid is one of the most common acids which is used as a cleaning agent in households to remove scaling deposited on floors due to hard water. Industrially, hydrochloric acid is used to descale water boilers, supply lines containing water and to loosen the rocks in petroleum industry. Industrial glue is obtained by treating biological material with hydrochloric acid. Hydrochloric acid, when combined with concentrated nitric acid in the ratio of 3:1, forms strong acid known as aqua regia. Aqua regia is used to dissolve noble metals. Hydrochloric acid is also used to clean metal sheets in metallurgical industries. Hydrochloric acid is also secreted in our stomach, which helps in digestion of the food. Applications of nitric acid. Nitric acid is a nitrate containing acid. Therefore, it finds its application chiefly in manufacture of nitrogenous fertilizers. Nitric acid is used to purify precious metals like silver and gold. It is also used in metallurgical operations. Nitric acid, when combined, toluene forms TNT, which is a strong explosive. It is also combined with glycerine to form trinitro-nitroglycerine, which is a liquid explosive. It is also used in making aqua regia. Applications of sulfuric acid. Sulfuric acid is also known as king of chemicals because of its widespread applications in manufacture of different types of chemicals in industry. Sulfuric acid is used to manufacture fertilizers like ammonium sulfate and single superphosphate. Copper and zinc sulfate are manufactured by treatment of sulfuric acid with copper oxide and zinc metal. Sulfuric acid is used in diluted state as an electrolyte in the lead acid batteries. Sulfuric acid is used in cleaning of leather and removing excess of dyes. Sulfuric acid is used in manufacturing of medicines. So, the book explains the uses of different acids so beautifully. Now, let's come to bases. Now, what are bases? As we discussed, they are substances which have got a slippery touch. Now, when bases are mixed with water, they become alkalis. Not all bases can mix with water. Some can. Now, they again, like acids, bases are also strong and weak. What are strong bases? They are oxides and hydroxides of metals such as sodium. And what are weak bases? They are oxides and hydroxides of metals such as calcium. So we know that they are bitter in taste, they are soapy to touch, and they are corrosive in nature just like acids, and they can also burn the skin. Getting back to the chemical properties, children, when these react, bases when they react with acids, we know that they give out salts and they give out water. So, where are these bases used? These bases are used in agriculture, as we discussed earlier also, in industries where raw leather is treated with bases to clean it up, in households as cleaners and as polishers. Now, again in your book, there are some examples of common bases like ammonium hydroxide, sodium hydroxide, magnesium hydroxide, sodium hydrogen carbonate, sodium carbonate. All these have got different uses in our daily lives, which you can read yourself. Now, let's come to what is formed as a result of combination of acids and bases. They are salt. So, we know that a salt is going to be neutral if the acid and bases are equal in strength. It is going to be acidic if the acid is stronger, and basic if the base is stronger. Now, preparation of salts require a neutralization reaction. What happens when an acid is mixed with a base? When acids mixed with bases, they neutralize each other and the resulting liquid is neutral. Such a reaction is called a neutralization reaction. Ask your teacher to take a test tube and add 10 ml of dilute hydrochloric acid in it. Observe its color. Next, add 2 drops of phenolphthalein indicator to it and shake gently. Keep adding sodium hydroxide solution drop by drop and shake gently till the color of the solution becomes pink. Now, add 1 drop of dilute hydrochloric acid to this solution. You will find that the solution becomes colorless. If you again add a drop of sodium hydroxide solution to it, the solution in the test tube becomes pink. If you feel the test tube from the bottom, it feels warm. You can conclude that when dilute hydrochloric acid and sodium hydroxide are mixed in right proportions, the acids and bases neutralize each other and the resulting liquid is neutral. Neutralization reaction would mean, as we discussed before, that both the acid and the bases have to be equally strong. So, a list of reactions have been given. Similarly, a salt can also be made by the reaction of a metal with an acid, a vegetable oil with alkali. Now, what are the properties of salts? Salts are usually shiny crystals. They are hard and rigid and they have high melting points. They are soluble in water and they can conduct a good amount of electricity. Now, what are the uses of salts? We all are aware that common salt or NaCl is something we use to flavor our food. Then it is also used to serve to patients suffering from severe dehydration in the form of ORS. Then sodium hydrogen carbonate is known as baking powder. It is an important part of our daily cooking. Sodium carbonate is washing soda, which is an essential component of all the detergents. Then there is copper sulfate, which is used in preparing the Bordeaux mixture and also in the preparation of glue. Potash alum is used to purify water. Then there is bleaching powder, which is used again for purifying water for the chlorination of water. Then there is ferric chloride and potassium permanganate, which are used as disinfectants. Now children, we have studied acids, we have studied bases. If I give you a bottle which has got a clear liquid, how will you tell me whether it is an acid or a base? For this, we need indicators. And to understand indicators, we need to watch a video. Most bases and acids are colorless liquids. So how do we know whether a substance is an acid or a base? Special substances called indicators are used to test whether a substance is an acid or a base. An indicator shows different color in acids and bases. Some natural indicators are turmeric, litmus, China rose petals. Some man-made indicators are methyl orange and phenolphthalein. The most commonly used natural indicator is litmus, that is extracted from a small plant called lichen. In distilled water, litmus gives a purple color and it is called a neutral litmus solution. The neutral litmus solution turns red when added to an acidic solution and blue when added to a basic solution. So children, in this chapter, you have learned how acids and bases are totally different from each other, not only in their physical properties, but also in their chemical properties. We have understood the combination of acids and bases and how they form salts and a variety of uses of all the three. So I hope you are ready to attempt the questions at the back. Thank you.